You may know the term mole, referring to the fuzzy little creatures or the flecks on your skin. But a mole measures the amount of particles or chemical entities, as there are atoms in 12 grams of carbon-12, in the mass of substance, element, anything you want. Basically, 1 mole equals 6.022 times 10 to the 23rd chemical entities of this type of carbon. A mole is so small that something as small as a pencil can have millions and millions of them, more even. Avogadro's number helps calculate these large numbers.
Avogadro's number was named after Amedeo Avogadro, who was one of the first physics professors in Italy. He proposed that equal volumes of various gases contain the same number of particles when at the same temperature and pressure, and the amount of chemical entities equal the physical mass of a substance. Avogadro, although did not determine the proportions, was still given credit for the idea. Joseph Loschmidt was actually the first to predict the amount of particles in a substance, which later developed a different number called the Loschmidt constant. The mole has been used by many scientists and calculated in a variety of ways. Jean-Baptiste Perrin, a French physicist, used Avogadro's number to report Brownian motion, which is the haphazard movement of particles contained in a liquid or gas. To correctly calculate Avogadro's number, one must measure a single quantity on multiple scales, macroscopic and atomic, with the same units. Robert Millikan measured charge on electron, which was important because people were able to discover Avogadro's number by dividing the charge of a mole of electrons by the charge of a single electron. It can also be calculated with measurements of density of a pure substance on a macroscopic scale. The density can then, on the atomic scale, be measured to determine the number of atoms per cell using X-ray diffraction.
What is molar mass then, and how does it factor into chemistry? Molar mass is the measured mass of individual moles in a substance, element, or compound. It helps scientists to connect mass with the amount of moles. Molar mass is important for samples and experiments. People often get confused between atoms, moles, and molar mass. They seem to be jumbled up together a lot in chemistry, which all relates back to dimensional analysis. We convert mass to moles, then to atoms. Molar mass is calculated by dividing the mass of a chemical material by the amount of substance or mole. Mostly, it is calculated by adding the atomic masses. It's easier than it sounds. Let's say you have a compound of 2 borons, 1 carbon, 1 oxygen, and 3 iron. Look at the mass per element, just add them all up. For borons, you would calculate the mass to be 10.81 units times 2 because we have 2 boron atoms. You would do the same for carbon, oxygen, and iron with their respective masses, then add all these variables to create the total mass.
So now we're going to test what you guys know. Here are some practice questions. What is the molar mass of sodium chloride? What is the molar mass of potassium nitrate? When did Avogadro come up with his number? What are 2 examples of how mole can be calculated? Convert 47 molecules of helium to atoms. Okay, so here are the answers to those questions. 5 grams of sodium chloride equals... The answer is 51.5 times 10 to the power of 20 mole. 7 grams of potassium nitrate equals... The answer is 4.148 times 10 to the power of 22. The answer is 1811. Now this is what is an example of how mole can be calculated. Measure on multiple scales, macroscopic or atomic, and density on 2 scales and X-ray diffraction. And now for the last one. The answer is 2.83 times 10 to the 25th power.